So welcome to our November edition of Tunnel Talk. This one is extra special. The On-Farm Climate Action Fund has presented the opportunity for us to bring in a couple experts on nitrogen management and cover cropping for winter spinach production. And so before we get into it today, I just want to go over some upcoming events. We're officially transitioning into our meeting season and conference season, which is exciting. So we're going to have sort of a mix of virtual and in-person events starting to crop up. So in December, this webinar, we're going to do a little bit of a different format. We're going to be looking at sharing on-farm experiences. So this is a little bit less formal and just an opportunity to say, you know, if maybe I tried something different this year, I can talk about it for 5-10 minutes. Yeah, and just kind of talk about some of the experience that people have on farms that, you know, we'd like to share with our neighbors, with our buddies. January 4th, we're going to do a session on strawberry production. I think that's most likely going to be based in soil as opposed to hydroponic strawberry production, but the focus will be sort of the indoor spaces. We're hosting a series of nutrient management planning workshops through the first 2 weeks of December. So really keying in on nitrogen application and choosing our nitrogen sources. This is going to be commodity specific. So whether you are growing field crops or orchards or grapes or wild blueberries or greenhouse, we're going to have something there for you. So this will be an awesome session and I definitely recommend you check it out. So last year I did attend the Dane County Extension. They had a virtual organic vegetable production conference. I don't know, Genevieve or Judd, did you see that one last year?
I don't think I did.
It was pretty good. I was impressed with sort of the topics. I believe it was 2 full days of programming. So I'm not quite sure what the agenda looks like for this year, but I definitely recommend people check that one out. I thought that was pretty good. And then we have our Horticulture Congress is doing their annual conference January 27 and 28. Yeah, so I think those are kind of the ones of note now, but obviously our calendars are going to be filling up in no time. So with that, we're going to jump into our presentation. We're going to start with Genevieve. She'll be talking about cover cropping in winter spinach and some of her work there. And then once she's done the presentation, then we'll sort of switch gears. So just before she gets going, Genevieve is an extension educator with the University of Massachusetts Vegetable Program with a background in IPM and plant pathology. The extension vegetable program has looked at downy mildew resistance variety trials in cucumber, reduced risk pesticide evaluations, and evaluations of heat tolerance in vegetable crops as well. So lots of interesting and relevant stuff there. So I am going to turn that over to you.
Let me share my screen. And you guys see the right one?
Yes, looks good.
Excellent. Okay. So yeah, hello, my name is Genevieve Higgins. I'm an extension educator at the University of Massachusetts. And yeah, Talia asked me to talk a little bit about our winter spinach fertility work, specifically a little bit about cover cropping for winter spinach. I don't have a ton of slides. We have just kind of like dabbled in this in our research program at UMass, but I'll kind of go over what we've worked on and then turn it over to Judd, who will speak next. So just briefly what I'll talk about the spinach fertility recommendations that we make for growers and that we follow for our trials. I'm going to briefly mention salt buildup in high tunnels, which is related to fertility and something that folks run into issues with. And then I'll talk a little bit about our work with cover crops. Let me turn on my laser pointer. And I'm happy to be interrupted with questions or do questions at the end or after Judd's talk, whatever makes sense. So these are this is a bit about the spinach fertility requirements and recommendations that we follow. Spinach in the winter in high tunnels grows really slowly, and it has relatively low nutrient needs. And in combination with that, folks are often growing high tunnel spinach following a summer high tunnel crop, and there's often residual nitrogen in the tunnel from those summer crops. So we always recommend that folks take a soil test in the tunnel, at minimum testing for nitrate before they fertilize in the fall. Spinach will definitely suck up nitrate, and it can get pretty high in the foliage, which isn't great. So it's a good idea to test and save your money, save your labor for spreading fertilizer if you need to. These are the nutrient recommendations. This field spinach recommendation is from the New England Vegetable Management Guide, which is available online, and has nutrient recommendations as well as many other recommendations for all the crops. And you can see it's much higher. The nutrient recommendations are much higher for field spinach compared to tunnel spinach. These are the recommendations that we follow for our trials. And you can see in these pictures down below, this is just an example of a tunnel from one farm in Massachusetts. This is a tunnel that was seeded on October 12th, which is kind of the end of the spinach seeding window for us down here. And you can see more than a month later, it's like maybe at a 1 or 2 leaf stage, but still small. And then in December, it's not even harvestable yet. So it grows very slowly. It's not putting on tons of foliage. It doesn't need tons and tons and tons of nitrogen in order to take off. However, on the kind of flip side, we do commonly see this yellowing in spinach, usually it's in late February down here when the day length starts to increase again. So you seed your spinach in the fall, it germinates and grows slowly, has kind of an initial flush of growth while the weather is still relatively warm and the day lengths are long. And then we enter the Persephone period, they call it. So when day lengths fall below 10 hours per day, and basically the spinach doesn't grow very fast at all. Sometimes you can push it along with supplemental heat, but the day length really does make a difference. So down where we are, at least in like mid-late February, the day length starts increasing again, and the spinach will start taking off again. And it's pretty common to see this yellowing at that point. So we usually recommend that folks test for nitrate again, soil nitrate, at the end of that Persephone period and side dress if the nitrate is below 30 parts per million. However, we were reviewing our vegetable management guide this winter, and in the spinach section, there's this part that talks about magnesium deficiency. And Judd, I'm not sure if you know more about this and can speak to it later on, but it mentions that magnesium deficiency can also cause yellowing, and to do tissue testing to diagnose that and apply magnesium sulfate if the magnesium is low, and to do that before you side dress with additional nitrogen. And so I don't have direct experience with that, but I'm interested to test it out and see what we find this winter in our trials. It's interesting. Okay, a little bit about salt buildup. So fertilizers contain salt. They are salts, basically. It's not a bad thing. It's just a fact. And in the field, you apply your fertilizer, and then there's natural rainfall, and the salts kind of continuously are washed down in the soil. Hopefully not too much. You don't want things to be leaching out, but they're kind of continuously washed into the soil. In the high tunnel, you're basically growing in like a desert, though. And without that natural rainfall, water, along with the salts that are dissolved in that water, is constantly getting wicked to the surface by just evaporation off of the soil surface and being taken up by the plants. And so as a result, in high tunnels, salts can build up in like the first few inches of the soil, and it can be damaging, especially to shallow rooted crops like spinach or other salad greens. This first table over here is a table of salt tolerance of different vegetable crops. Excuse me, you can see spinach is relatively pretty tolerant compared to some other crops. But these values are showing like 50% yield reduction. You obviously don't want to have a 50% yield reduction. So it can definitely, spinach can definitely get damaged by salt buildup. The easiest, or maybe not easiest, the best way to reduce salt buildup in those top 2 inches is when you're reskinning your tunnel, which I know they say to do every 3 years, and most people don't actually do it every 3 years, but whenever you do it, the best thing is to keep that plastic off over the winter, if you can manage it, to let rainfall and snow flush those salts back down through the soil profile. And if it's not possible to keep that plastic off, then just irrigating and flushing things as much as possible in between summer and winter crops, so that you're not damaging crops. And then this table over here, more for folks' reference, this won't necessarily mean a lot just right now. It's just a table. There's 2 different methods of, or at least 2 different methods of measuring soluble salts in soil. There's one called the saturated media extract, and one is the 1 to 2 method. And these are the kind of the thresholds for when you might start seeing issues in a crop. And I can't speak to up in that region, but down here at our soil lab, you can request just a soluble salt test for soil. You can add it on to a standard soil test. So it's fairly fast and easy to get that tested if you're concerned. Okay, so a few slides about cover cropping in high tunnel spinach. Obviously, cover cropping is a widely adopted practice in the field these days, and the benefits of cover cropping are well understood by growers. In addition to growing your own nitrogen if you're growing legumes, and having living roots in the soil, and providing aeration, and a whole world of benefits. In tunnels, it's folks, at least in our area, are slowly kind of adopting cover cropping in tunnels. It's hard to do because it's a really high value space, the high tunnel, and it's hard to take a tunnel out of production to have a cover crop in there. But kind of more and more growers over here are getting to points where they're really struggling with soil-borne diseases, or they're having productivity issues. And so we're seeing more growers kind of, especially if they have more than 1 tunnel, like take 1 out of production to cover crop for the summer. So if you can manage that, you can obviously cover crop during the summer, nice long term. But if you don't want to take out a tunnel for an entire crop period, you can probably fit in like a quick buckwheat cover crop or something else fast between a summer and a winter crop, especially if you push a summer crop to be done a little earlier, or push a winter crop to be seeded a little later, just to fit that in. And the thing I'll talk about a little more with cover cropping in tunnels is the fact that incorporation of cover crops, or incorporating that green manure, people call it, provides food for soil microbes. All soils contain, tons of microbes, good, bad, neutral. Pathogenic soil microbes, so pathogenic fungi and fungal-like organisms, are often fairly poor soil competitors. Like they're not that great at scavenging for nutrients and competing with other organisms. So there's a concept out there that if the incorporation of green manure or cover crop residue provides food for all the soil microbes, but by providing that food, the beneficial microbes that are already in the soil will kind of be strengthened and more able to outcompete soil-borne pathogens. So that's something that we looked at maybe 2 years ago, 3 years ago. Now I can't remember how many years have passed. We were looking specifically at winter spinach, and looking at trying to reduce damping off in high tunnel spinach using this method. So damping off, this picture down here is a picture of some damped off spinach. It's a disease caused by several soil-borne pathogens, both fungi and fungal-like organisms. So like oomycetes like Pythium. And the pathogens are ubiquitous in most soils, but they're usually weak pathogens, and can only cause disease when plants are already weak, or in really young plants, or when growing conditions aren't ideal for a crop. So we see it a lot in spinach when the weather is really cold, the soil is really wet, the spinach is germinating slowly. All those conditions allow the damping off pathogens to infect either the seeds or the germinated plant, and just cause bad germination and poor stand. So it's an issue we see a lot in high tunnel spinach and in the field, actually. And our growers struggle a lot with it. And so this trial, we looked at a few different factors. I'll talk mostly about the cover cropping, but we looked at 2 different varieties. We looked at priming the seed in order to speed up germination to reduce the damping off, which in this case didn't work, and I won't talk about it, but and then we looked at the cover crop incorporation. So this is a bit of a timeline. These 3 pictures on top here of what the preparation looked like. So over the summer prior to the trial, one half of the tunnel had a unrelated cucumber trial going on. And then the other half of the tunnel was seeded into buckwheat for the summer. And then September 9th, we mowed and incorporated that buckwheat shortly after the cucumber trial was finished, and that was all taken out and also tilled in. And so we ended up with a freshly tilled tunnel. This side had cover crop on it. This side had no cover crop on it. And we seeded our spinach trial into that. So this is the same orientation. This side had the cover crop that was incorporated. This side had the cucumber trial that was removed. And give me a second here. Right off the bat, you can see that the cover crop side was wildly more productive than the uncover crop side. You can just see the plots are super lush, versus this one has some really patchy plots. Let's see, I can go through. There was the main thing, I'll talk on the next slide about the effects on damping off and germination and yield, which got a little complicated, but the main thing that we took away from this trial was that the cover crop just added so much nitrogen into the tunnel. It was frankly a little surprising, and in a kind of nice way. This was a kind of timeline of the management of both sides of the tunnel. So prior to the cucumber trial that we did, the non-cover crop side got some added fertilizer, 50 pounds per acre of nitrogen, and then we planted the cucumbers and they grew in there all summer, versus the cover crop side had no added fertilizer at that time, and we grew the buckwheat into that side. Then October 1st, we seeded the spinach onto both sides. And by the end of October, the side that had cucumbers, the soil nitrate was 15 parts per million, versus the cover crop side that had the buckwheat incorporated into it had 32 parts per million nitrogen. So based on our recommendations, we were supposed to side dress this side at this point. This was like below our side dressing threshold. And then this trend continued. So the buckwheat side, this side over here, the nitrate kept on rising over the next year and a half, 2 years. And I got up to 75 parts per million nitrate. And that was without adding any nitrogen fertilizer at all. So it was just nice to see that you can grow so much of your own nitrogen, and the addition of that organic matter just then being in the soil to release more nitrogen and fertility slowly over time was nice to see. This is a little bit of the data. So looking at just the germination of the plants, as I mentioned before, we trialed 2 different varieties, Colibri, which is an older variety but is still widely used, and Crosstrek, which is a newer variety that's catching on a bit now. The colibri overall had lower germination, and in the case of the colibri, cover cropping, which is the green bar here, cover cropping did significantly increase the germination of the colibri. In cross-trek, the variety had very high germination regardless, and there was no significant effect. And in terms of yield, we saw that the cover crop plots had significantly higher yields for both varieties. So that's these two green bars, significantly higher yields. However, the big however is that we did not control for soil nitrate in this trial, as you saw in the last one. The cover crop side ended up having way higher soil nitrate than the uncover crop side. And so the question remains, were these results that we saw, the germination increase and the yield increase, it could just be from one side, one treatment having way more nitrogen available in the soil than the other, or it could be some combination of both. And we haven't done more trials yet to kind of tease apart those two different factors, but it's something we're certainly interested in looking at. And regardless, it was encouraging to see just the amount of nitrogen that you could provide for your crops, especially a relatively low need crop like spinach, like winter spinach, just using cover crops. So with that, I'm happy to take questions, or I'm happy to pass things on to Judd, whatever makes most sense.
Awesome. So yeah, I think we'll start with questions, and yeah, I guess you guys can kind of tag team them if they overlap for both of you.
Cool.
But just before we dive in, to clarify, so are you planning on kind of revisiting that work
We're
where
not
you're kind of
looking at it.
controlling for?
Yeah, we're not
Yeah.
looking at it this winter. But it's definitely like in the back of our minds as like we need to figure that out.
Totally. Yeah.
The grant funding that we had specifically for that project ended, so we don't have like any immediate plans, but it's in the back
Just on the back
of our
burner.
minds for sure.
Okay. So first question, can you say anything about the relative salt contents of various fertilizers? Example, blood meal, feather meal versus compost versus a conventional nitrate fertilizer. So that's a big one.
Ooh, Judd, do you know that off the top of your head? I would have to look it up. I don't know off the top of my head. There's certainly
Well,
resources out there for it.
So most conventional fertilizers should all have a salt index on the label, and they don't always, but you should be able to get one. And then that salt index, I forget, it's close to a 1-to-1, a 0 to 100 scale, I believe, somewhere in there. And the lower the better, but that's not always easy.
And then I think
also there's certainly like some tables out there for like the organic ones.
then when it comes to something like compost, like that's going to vary depending on the compost. So in that case, like always recommended to submit that for a compost analysis, which we can do at the department lab in Truro, which is great. Off the top of my head, I know feather meal typically has lower salt content compared to some of the other options. I don't know about blood meal off the top of my head, but
I think that's pretty salty. I don't have a value for it, but I think there's a fair amount of salts there.
and I think regardless, like if you're kind of in the process of evaluating like different fertilizers, sometimes a supplier will have sort of that compost analysis that they can present to you. And if not, like you can test any amendment. We did a small nitrogen demonstration this summer, and we submitted our feather meal in just so that we could know how much nitrogen we were applying, but then also sort of look at some of that background stuff. So it's a quick, easy test. I don't think it costs that much either. When you talk about your 1 to 2 method for assessing salty soils, is that sort of your like more, I would say, homemade? I'm taking a 1 to 2 slurry and I'm sticking an EC probe in there.
Yes, you can definitely do it if you have the EC probe, which I don't think they're wildly expensive, but yeah, you make a 1 part soil to 2 parts water slurry, and let it sit for a certain amount of time. I think it's half an hour, and then you filter it through. We do it through some coffee filters, and then that filtrate you stick an EC probe in there, and we have a video of the process. It is very easy to do as long as you have the EC meter.
So- No, I'll include that as a resource in the follow-up email. But yeah, and I do recommend getting those probes. I find that they can be used in a lot of different ways. I feel like, yeah, it kind of just keeps coming back as this cool thing to be able to talk about.
Yeah.
And I just wanted to take a really quick second. We'll see if this shares properly. When we're talking about the saltiness of conventional fertilizer, let me see. Can you guys see that?
Yep.
Yeah. So oh, you're probably seeing the wrong one here. Hold on.
That's a triple 20 is what we're looking at right now.
Are you seeing the notes?
No,
Oh, great. Okay.
Yeah.
Man,
you
keep
got
me
it.
on my toes. So yes, on some conventional fertilizers, they have, let me see if my animations are gonna work. There we go. There was sort of this dilution rate table on this particular label, and they actually look at your EC depending on the ppm that you're using the product. So this is kind of a cool table to reference, like especially if we're comparing different types of conventional fertilizers and we're making a decision on maybe which one is a better suited for us. I think this kind of captures like maybe additional salts pretty nicely. So I don't know if we can necessarily compare that in the same way to a meal in terms of saltiness, but I do think it gives us an indication of like maybe a product is overly salty or less salty if we want to go to the conventional route. So keep an eye on this if you guys are looking at conventional fertilizers. Again, I don't think it's like a recommended, we're going to see it every time, but kind of a cool bonus when we do find that. Next question, did you study heated or unheated tunnels? And then the part 2 is how does heat or type of heat affect your research?
Our research tunnel is unheated, and at least where we are down in Massachusetts, you don't need to heat the tunnels to successfully grow spinach, although as I said, it will push things along faster if you're trying to hit certain harvest dates. And now I can't remember the second half of the tunnel. How much does heat affect our work or spinach in general?
Does it affect the type of, how does heat or the type of heat affect your research?
So this is the only spinach nutrient research that we've done. So as I said, like we've just dipped a toe in. Usually most of the spinach research that we do is plant pathogen related, plant disease related. Heat in general, Judd can certainly say more about this, but heat in general, if the soil is warmer, then soil microbes are going to be more active and going to be metabolizing things in the soil and probably making nitrogen more available for plant uptake. I don't know how much I don't know what the threshold is, you know, if there's a difference between soil microbe activity between 35 degrees and 38 degrees, because usually you're not heating your tunnel to a toasty 60 in the middle of the winter, but yeah.
What do you think, Judd? Any
I am going
thoughts?
to talk about this in my presentation a little bit. We have one study to share. The question there's a couple questions there are looking at. I think in soil heat is going to be most appropriate for the setting compared to say forced air. And I wonder, I think the warmer that is, probably the more mineralization of nitrogen you're having, so that more is becoming available. And the real question is, does that increased mineralization justify the cost of whatever your heating fuel is? That's the real question for me.
Awesome. Yeah, and I like that you kind of focus on even like the microbial activity is going to change depending on the heat. So in an unheated tunnel year to year, we could see very different rates of mineralization or even disease pressure. So that's a tricky one. So unless you kind of go in that fully controlled space where we can set it at 35 and 40 and 45 and 50 and really try to tease those values apart, it's kind of a tough one to
It
really
is.
nailed down.
Yeah,
Yeah.
and that's the theme. I imagine Genevieve has seen this too, is that winter vegetable research, there seems to be an outsized influence of your seasonality on your work, and farmers share this too. Or how much sunshine did you have, and your temperatures. And small changes in those seem to make an outsized difference on winter production compared to summer production.
Yeah,
Yeah, you're right on the edge
absolutely.
of, a plant's tolerances. Yeah, things make bigger differences.
Okay, and then the last question, did you try pre-treating spinach seed with trichoderma or watering some in?
We didn't. My boss and coworker Sue Schweifele had done previous work looking at in an on-farm trial, so on a farm that grows a lot of winter spinach, looking at a bunch of not treating the seed, but applying things like trichoderma, root shield, stuff like that, to the beds. And let me pull up the her trial results and I can put it into the chat. If I'm remembering correctly, some of the materials she did like a lab portion of this trial also, where she grew out those beneficial organisms from the commercial products in the lab. And some of them grew better at like the winter spinach temperatures. Some grew better than others, which was interesting, but I don't think she had any significant effects in the tunnel itself, just because there's so many factors going on in there. Again, looking at damping off. But I'll pull up
Yeah,
those trial results and put the link in the chat.
no, that sounds awesome. I have a quick question. Why did you guys choose buckwheat as your cover crop for this? What kind of went into that
We weren't
decision?
sure on the timing of the trial, like when we would be able to get it in and everything. So we're like, if we do buckwheat, we're sure to be able to fit it in. And then we ended up getting it in earlier than we might have planned. So it was a timing security thing. In the end, it was a pain in the butt because it went to seed and then became a weed. So we weeded out a lot of buckwheat from that trial. So as always with buckwheat, if you're using it for a fast cover crop, make sure you're mowing it and tilling it in before it goes to seed. Otherwise, it really can be tricky to get rid of. Although it weeds out very easily, but pain in the butt.
Was that sort of your plan, was to have it sort of mowed and incorporated before it sort of went to flower/seed, and then it just kind of happened faster? Yeah.
Yeah. And also with the added heat of the tunnel, like it's just things are different in the tunnel, and yeah, got away
Nope.
from us a little bit.
Super fair.
Yeah.
All right, do we have any other questions on this first part of our chat today? You guys are also, feel free to unmute. We all have that flexibility. Alrighty, so I think with that, thank you so much. I thought that was super cool. Really excited to kind of see what the next work kind of brings, and maybe the extension on that work in a few years once you guys are able to pull that off. So then up next, we've got Judson Reid. So for those of you who haven't attended our previous sessions with him, he is a senior extension associate with Cornell University Cooperative Extension. In his position, he manages a series of research and education projects for greenhouse, high tunnel, and field production of fresh market vegetables. He's done a lot of work evaluating grafting on tomatoes, biological pest control, cover cropping techniques, and soil nutrient management in protected ag. So with that, take it away, Judd.
Thank you, Talia, and thank you, Genevieve. I hope other people learned some things in Genevieve's presentation. I did. I do related work with cover cropping in high tunnels, but I'm looking more at winter cover cropping for a summer crop. So it was educational for me to see Genevieve's work there, looking at summer crops like buckwheat for a winter crop such as spinach, and very encouraging results too. So I'm going to share a series of research trials that we've run on fertility for winter spinach, so amended fertility, fertilizers, compost, etc. And I'll tell you right now that this is not a very clean story. Whereas Genevieve showed this nice yield bump from and nitrogen bump from a cover crop. Our data here on nitrogen sources isn't quite as conclusive, but I'll try to walk you through the work that we've done, and you can make some of your own conclusions. I will share from the get-go that I'm going to be using imperial units. Talia and I talked about this at another time. I occasionally do try to convert to metric, but inevitably I make mistakes. And it's probably just easier for me to use the units I'm familiar with, not that I feel they're superior in any way. So take what I say and adjust it to units that you're more familiar with. So nitrogen considerations for a winter crop in a high tunnel. 3 questions that are really interdependent. And the first of those is going to be source. And so where's the nitrogen coming from? We've heard a couple of different options here: blood meal, feather meal, other meals. You could even use conventional sources if you were so inclined, such as urea. And then a question, really the most important one that we've looked at, is rate. What is that rate? And Genevieve shared a field spinach versus a tunnel spinach rate. And we've examined some of those. And then timing or date. When is the right time to apply that? So these are the considerations that go into making decisions around nitrogen applications for winter crops in tunnels. And I'm going to give you my conclusions up front, really, though. First and foremost, we're generally looking at a pre-plant incorporated form of nitrogen because even though we could inject a soluble nitrogen, organic or conventional, generally I see drip tape in these settings, it doesn't really work in the wintertime, as we have very few irrigation events. And it's similar to field production. If you rely entirely on injected fertility, you can run into problems if you have saturated soils for a couple of weeks and you simply can't irrigate further to get that nitrogen out. Again, some of our conclusions: your more fast-acting, higher nitrate sources of nitrogen, I have Chilean nitrate or blood meal here, generally going to provide an early boost when compared to your more stable forms of nitrogen, such as an alfalfa meal or a feather meal. That doesn't mean that it is the way to go. It means that that decision is interdependent with some other factors, particularly timing. Those meals will oftentimes provide more nitrogen later in the season. And again, looking at Genevieve's data, her nitrogen from a cover crop actually increased over time. I think it went from 30 up to 75 ppm over time, over the course of a year or two. And meals act in a similar fashion, that you're going to have a release of nitrogen later in the season. And when I say meal, I mean alfalfa meal, feather meal, soy meal, peanut meal as well. And a combination of those quicker release nitrate sources and those meals actually can offer the benefits of having some early yield bumps as well as long-term nitrogen. So next, that big question is rate. And our data is very mixed, but from trends and grower input, our current recommendation, believe it or not, is pretty high. It's between 130 and 200 pounds of nitrogen for winter greens in cold soils. So that cold soils is a key term there. If you're heating your soil, I would suggest you could actually decrease that rate. You might be able to cut that in half, because if the soil is warm, then the microbes are active and they're mineralizing that nitrogen much more effectively. So kind of a bit counterintuitive, but you may be able to lower your rates in warmer settings. We oftentimes think about our spinach crop coasting on leftover nitrogen from a summer crop of, say, tomatoes. But more and more, I'm convinced that our summer crop is probably picking up leftover nitrogen from these very high rates that we're using for winter spinach. Again, the PSNT test is very important, I think, for making these decisions on rate. And also remember that high organic matter soils are going to be releasing end when conditions permit, specifically temperature and moisture. So a high organic matter soil could probably get away with lower rates of pre-applied nitrogen than a soil with a higher mineral fraction. And oftentimes I find people do have very high organic matter soils when they're growing under protection. And then the final consideration here is date. So later plantings are generally going to benefit from higher rates of non-nitrate forms of N. So that's, again, the meals that I'm talking about, feather meal, for example. Mineralization is very cold in cold soils. And those non-nitrate forms of nitrogen are going to be able to supply nitrogen later in the spring when your late plantings have their highest yield. So now the question is, what is early and what is late? And again, Genevieve mentioned something called the Persephone period, and I just want to show you real quick a way to calculate that. Roughly, we are talking about 10 hours of daylight is when these plants are going to stop growing. So that's what I'm using to call an early or a late planting, which again helps me make some decisions around what type of nitrogen to add and how much to add. So there's lots of places you can see this online. This is almanac.com. You can browse by province or state and see what is the day length. For example, let's choose, I think I saw Kentville on here. Well, let's do this one. Well, let's do Truro. So we can see we have, right now, we have just fallen underneath that 10-hour period of where we're going to have active plant growth. So at this point, it's a late planting. You go to another location, here's Yarmouth, and that's, again, there is a difference there, almost 10 minutes of difference of daylight. So I thought that was a fun tool. Check it out for a location close to your farm and figure out when are you actually entering into that late planting period, as I call it. Okay, we're back to a PowerPoint now.
Yes, we are. Looks good.
Thank you, Talia. So this is Dave and Cindy at Pleasant Hill Farm, where I was fortunate to join Talia on a farm meeting a summer or two back, and you can see here David is demonstrating an injector that would allow us again to deliver very small doses of nitrogen. He actually, I think, has some acid there along with it to lower the pH of his irrigation water to make sure that those nutrients are available. And again, this in many ways would be the preferred option, that we could just put out very small doses of N as we need to. However, my experience and what growers share with me is that they would just as soon avoid irrigating as much as possible in the wintertime. So really, this is a tool I think more for summertime applications. Before we go any further, I want to thank Talia and Perennia for inviting me here. They're an outstanding resource. If you're a grower in Nova Scotia, I would highly encourage you to be in contact with Talia. She can help you through a lot of the decisions that we're going through in this. And then I have some contributors here in New York State that I need to acknowledge as well, and their names are listed there. So thank you to them. An important point when we talk about growing in high tunnels or winter growing in general is that really I find we're talking about growing in low tunnels, and here we can just see the near daily routine of the removal and application of row cover. And how this matters for nitrogen is that those row covers are trapping infrared wavelengths down in the soil in the crop when they're applied at night. They keep heat closer to the soil. and the crop. And we oftentimes are thinking about how this is protecting from frost damage. But also it's keeping that soil warmer, and that is allowing more mineralization or more microbial activity, which is going to, again, give us more nitrogen. So it's an important point to make, in that we're going to apply those covers on hopefully a daily basis as soon as the sun goes down, and then remove those as soon as the sun is out in the morning. So sharing some of our research questions. First, we wanted to look at, does the source of organic nitrogen affect plant uptake or yield? And then later we looked at, does temperature affect soil nitrogen availability or yield? And then most importantly, how do these factors affect the profitability of winter greens? Where we do our research is here all the way to the left of my screen, where that red pointer is, just to give you an idea of where latitude we are compared to the province of Nova Scotia. And then in terms of a climate zone, the United States and Canada have two different plant hardiness ratings. The Canadian one, I think, is actually probably a little bit greater value, because it factors in more than just simply low temperatures, which is the USDA version. So just so you get an idea where we're doing our research, it's up here in the northeast corner of the state, in what we would call in the States, that would be a 5A, if I have that right. Just on the border between a 5A and a 4B. And again, this is a map of the Canadian provinces with the US hardiness zone imposed upon it. So you can actually see that much of Nova Scotia is a zone warmer than where we're doing our work, although some of it is actually in the exact same zone as where we're presenting this research. Soil test is essential. This is one of my colleagues pulling a soil test for our research in one of our high tunnels, and I think Genevieve made this point already. We use those soil tests even in our research to make sure, do we need to amend any nutrients ahead of time, so that we're not seeing a confounding factor if we're trying to research nitrogen rates. So in this case, we did need to add potassium to make sure that we were doing not evaluating that as well. Looking at date, we planted 2 weeks apart. We were using a variety space, and our first set of treatments were urea, which really I recognize people aren't using urea very commonly in high tunnel spinach, but that's in a sense our check, our conventional check at 130 pounds with a split application, and then a blood meal application split into 2. And then our alfalfa meal, again, is pre-applied. And then we have a no nitrogen treatment at all in this trial. And right off the bat, I want to point out that we have a major yield difference in our alfalfa treatment. And you can see that alfalfa treatment here is in the center, and that is actually our lowest performing plot there. It's performing less than our untreated control. This was a particularly cold winter, but I'm going to skip that data now. This is a better shot of some of our yield differences between control, the alfalfa meal, and the blood meal, and then you can see the urea back here in the left. So I'm curious, anyone's welcome to unmute and chime in. I've got 130 pounds of nitrogen there in my alfalfa meal plots. Why does it look worse than 0 pounds of nitrogen? Well, in the interest of time, I'll volunteer what I think is going on there is that, again, that the nitrogen in that alfalfa meal is not really in a nitrate form. It is still in an organic form or amino forms of nitrogen. And the soil microbes in the fall are going to go to work to further break down that alfalfa meal. And there's a high rate of it with 130 pounds. And they need energy to do that work. And they get their energy in the form of nitrogen. So there's actually, I'm creating a nitrogen competition in that case with that heavy dose of alfalfa meal. Our foliar results across all the treatments was relatively consistent, not big changes, and our nitrogen, which is represented here in this foliar sample all the way to the left, is firmly within the what we call sufficiency range. However, we have less leaves where we have the alfalfa meal. So looking at nitrogen trends from an early planting compared to a late planting, we can see that, the alfalfa meal here is the green line on the early planting, and it is at the lowest rate of nitrogen within the plant itself, but it does rebound considerably in March. It comes up quite a bit. However, we see that urea outperforms all of them. That's not a surprise. Again, that's more of just a check. Similar trends in our late planting, although I'll point out that our drop here is not as steep. We don't go below 4% nitrogen on a later planting. And I think that is because that earlier planting, we are going to have an earlier yield off of it. And so it's it runs into a deficiency sooner as well. In terms of yield, blood meal in this case gave us the highest peak yield. That's the blue dotted line in this chart. And that is with a late planting. So if you see early on at a harvest in October, our alfalfa meal is actually a quarter of what our blood meal is at that point. So again, for those, if you're trying to make a decision around date of application that's tied to an early planting, or a source, I should say, tied to an early planting, you're probably going to benefit from those quick release forms of nitrogen, such as Chilean nitrate or blood meal. I just want to check my time here. I'm 20 minutes into this. Okay.
Yeah, you got plenty of time.
I'm doing okay. Okay, good. I'm going to share a video then, hopefully. And does this look good to you?
Yeah, looks good.
Sharon?
Morning, everyone. I'm Judson Reid with Cornell Cooperative Extension, here with my colleague Elizabeth Hodgson of the Eastern New York Commercial Horticulture Team. And we're at the Cornell Willsboro Research Farm in one of our high tunnels where we conduct research on spinach. Specifically, spinach grown in the late fall, over the winter, and into the spring. And our research is focused on how much nitrogen, fertilizer nitrogen, does this crop require? What is the response of this spinach to different rates of nitrogen and different sources of nitrogen? We got into this work several years ago, and the reason was that growers, commercial growers, we found were using very different rates of nitrogen than what Cornell was recommending. For example, some growers told us they were using 200 pounds of nitrogen per acre. Others were up to 600 pounds of nitrogen per acre, whereas the Cornell suggested rate might be closer to 100 pounds of nitrogen per acre. Why does this matter? There's some concerns with putting out excess amounts of nitrogen in terms of nitrate accumulation in the crop, the fate of that nitrogen in the soil and in the atmosphere, and the cost to the grower of that nitrogen. Can we fine-tune our nitrogen rates? So over the last 4 or 5 years, we have been looking at the rate of nitrogen and the source of nitrogen and the spinach crop's response to this.
So yeah, we're here at the Willsboro farm today in Essex County. We're in a high tunnel that's just a single layer of plastic, unheated. The tunnel is 20 by 48 feet, so a relatively small high tunnel. We transplanted the spinach on October 1st this past fall, and our treatments consist of 2 different organic nitrogen fertilizers at 4 different rates. And so we're testing Pro Booster and Feather Meal. Those are both products available from North Country Organics. And Pro Booster consists of a mix of different plant and animal-based meals. It also contains some Chilean nitrate, which is a quicker releasing available form of nitrogen for the plant. That's a 10-0-0 product. We also tested Feather Meal, which is processed feather byproducts, and that's 13-0-0. And that is all feathers, and that's more insoluble than the Pro Booster. The Pro Booster, again, contains some Chilean nitrate, more water soluble nitrogen. We tested those 2 different fertilizers at 0, which is our control, our comparison, 65, 130, and 200 pounds of nitrogen per acre equivalent in our plots. And so we have these plots here today that are in a randomized complete block design. So these are our plots here, and we used a plant spacing that's similar to what the commercial high tunnel growers are using in our area. So we have 3 rows of spinach, and the rows are 6 inches apart. Each group of 2 plants is 5 inches apart. So we have a fairly dense planting. We started harvesting in early November. We had kind of a warm November this past fall, so we got 2 harvests in November, another in December. And during our harvest, we would harvest the whole plot and weigh that yield. And then, the spinach overwintered, and we had our first harvest of the spring about 3 weeks to 4 weeks ago. And then we're harvesting again today. It's April 9th. The spinach overwintered well, and we have some really nice green lush growth now that the days are longer and the temperatures are warmer.
So early on, our research suggested that the greens crop really did not need those high levels of nitrogen. We were seeing similar yield between no nitrogen or very low rates of nitrogen compared to the higher rates of nitrogen. However, our work here over the last couple of years, particularly 2020 over into 2021, is showing some response both to the source of nitrogen and the rate of nitrogen. So I'm going to ask Elizabeth to share with us, what do some of those results look like this spring? What did we see in the fall, and what are we seeing in the spring in terms of source and rate of nitrogen, Elizabeth?
So we did see the strongest differences, or the most noticeable differences in yields in our first harvest, which was at the beginning of November. So we did find, in particular, we harvested much more spinach from the 200 pounds per acre of Pro Booster versus the control.
Yep.
We found significantly higher yields from Pro Booster versus Feather Meal.
Yes.
And so we did see kind of, what we would hypothesize from a fertilizer experiment, where, the higher the rate of nitrogen, the greater the yield. And then in our second harvest in November, we also saw statistically significant differences between the control and then 130 and 200 pounds of nitrogen per acre.
So control was 0 pounds of nitrogen.
Yes,
right?
and I think there are some growers that sometimes might not apply any nitrogen when they're putting in their winter greens. Some people will rely on leftovers from tomatoes or other warm season crops. So
yeah, that was one of the original questions here, is can the winter crop, in a sense, kind of coast on any leftover fertility from the summer crop in a high tunnel?
mm-hmm.
But what we're seeing is maybe the opposite. Maybe the summer crop is coasting on some nitrogen that might be left over possibly from the winter crop. But if I understand you correctly, what we saw this past winter was Feather Meal, as you and I were talking about earlier, really does not have soluble nitrogen available to the crop immediately compared to the Pro Booster.
Exactly.
Which we're not trying to favor that product, but it's one that's commercially available and common in this part of the country. And it has multiple sources of nitrogen and particularly nitrate nitrogen that's immediately available. And you saw that this November, combined with warm weather and soluble nitrogen and a moderate to higher rate, so 130 or 200 pounds, the spinach responded with increased yield. And you and I just did a quick back of the envelope calculation that showed that that increase in yield could play out to be a couple $1,000s over the space of a commercial sized high tunnel, right?
Yeah, we were just using some spinach prices that we've heard from growers in our area. It could be, upwards of about $2,000 more harvest per tunnel. So yeah, I'm looking forward to, again, using our complete yield data and delving a little deeper into the economics and looking at fertilizer costs and just trying to fine tune that recommendation. But so we did see those yield differences in the fall, or in November, I should say. But then we also did another harvest in mid-December. So by then the spinach was growing a little more slowly as the days were getting shorter. And we actually did not have any significant differences between treatments for that harvest. And we didn't see any differences in our March harvest. So it could be just maybe that burst of, readily available nitrogen, and the plants are taking it up.
So we've got some results from this work. We're not done with it. We want.
Very good. So thank you for bearing with me on that. And I'm going to reshare my PowerPoint now, hopefully. So again, no endorsement intended there of any product, but the takeaway there is that a mixed source of nitrogen might be a good strategy, particularly for those earlier planted crops or a crop in a heated soil. Here's just a quick shot of the materials we were using in that trial. Now, I'll highlight here that our soil nitrate levels do indeed increase with the higher rates. That's not surprising. But look at the actual rates. They're not particularly high. If you go back to Genevieve's recommendations, I think her control plot had 15 ppm in it after a cucumber crop. And you can see here in these October and March samples, we still have, even with 200 pounds of actual N going in, we still have only 12 ppm of nitrate being available, not available, but testing out in those PSNT tests. And again, supporting that use of more soluble materials for early plantings, we can see here in November, there is a significant difference between particularly at the lower rates, Pro Booster and Feather Meal. So we wanted to really ground truth this research by having it not just at a research farm, but at a commercial farm. And many of you may be familiar with Paul and Sandy Arnold of Pleasant Valley Farm. And they hosted our trial for us here in 2021, looking at specifically peanut meal in this case, and going down to just those 4 different rates and looking at yields based on those. So again, here are those rates: 65, 130, and 200. And I will share right off the bat the data from this over time with two February harvests, a March harvest, and an April harvest. In terms of rate, in this case, it really did make a difference looking at 0 pounds compared to anything else, right? 65 being the orange bars and 130 pounds being the gray bars. And at this point, it becomes a question probably of the difference between 130 and 200 pounds in this case, which again was a little disappointing for me. I was hoping we could reduce these rates. And for some growers, we have been able to make the argument to decrease them based on this data. But again, you can see the 200-pound rate is providing quite a bit of yield deeper into the season. And again, this is with a peanut meal, 7% nitrogen, so it's a fairly high application rate, and it's available slowly over time. And we can see, in this case, we're harvesting a plot here in the foreground where those lower rates, you're just having much lower yield. And a lot of the yield is coming across the edge of the bed, the edges of the bed, where it's probably a little bit warmer. That soil is probably a little bit warmer, and we have probably a little bit better microbial activity. A little drier, I should say, as well. So here's some of the differences in yield on our, again, I wouldn't get hung up on the values here, but just the relative, the relationship between these values going from our control and peaking with our highest yield at 130 pounds on that February harvest. And now I'm going to let the grower speak, because that's more interesting than hearing me speak. Paul and Sandy, just wonderful people if you ever get a chance to meet or chat with them, and I'm sure many of you have.
This year, we have put in a trial here to look at the rate of nitrogen and spinach response to that rate of nitrogen. So we have 4 different rates. 0 pounds per acre of nitrogen, which is our control. We have 65 pounds per acre. We have 130 pounds per acre, which is close to the Cornell guidelines for spinach. And then we have 200 pounds per acre, which is something of a grower standard in the Northeast for winter spinach. The source of that nitrogen in this trial has been peanut meal. So we'd love to get your honest feedback on what you think about these different rates of nitrogen.
I think when looking at, because right here is the trial bed that they did, you know, the rest of them is all under our management of what we put down, is I think as you get toward the middle of the bed, it starts to show up the lack of nitrogen. As you go down, it starts to get a little greener and a little nicer, and the yield starts to come up a little bit. What they're using for a nitrogen source is somewhat close to what we're using, since we're using North Country Organics ProGrow, which is the non-Chilean 534, and that uses peanut or soybean meals as their nitrogen source.
I think it's going to also be interesting to see what happens to this spinach over the next couple of months, because we will be picking this until May. So whereas the 130-pound N actually looks pretty good, and I think the yield is very close to the 200-pound N at this point, in another couple months, we do find in the spring, as the spinach really grows, we're picking it more and more and more. We want it to have enough nitrogen. We don't want to have to amend if we don't have to. So I think the 200-pound, we've been really comfortable with that, doing that for many, many years with different trials.
Great, thank you. So kind of hard to argue with success, and they're very successful growers. I do want to highlight, though, that this is not a right or wrong situation. And bear in mind that what Sandy and Paul are doing there is growing over a very long time. They will harvest into May in some years in those high tunnels, whereas a lot of other people might have already swapped those out for warm season crops. So if that's the case, you may not need to go with those higher rates because you're not going to be harvesting spinach in April and May, whereas these folks are. See if there's any key findings here I want to highlight. Rates greater than 200 pounds per acre resulted in stunting at Pleasant Valley Farm. That's an important takeaway. The final piece of research I'm going to share here is around temperature. And real quick as a background, soil temperature, of course, influences nitrate levels and yield. We've covered that with microbial activity. Soil nitrate levels are generally going to be higher where temperatures are higher. However, does this increase in nitrogen availability and then potential yield justify the expense of heating? Now, I'll admit a major limitation of the trial I'm going to share with you is that we were looking at forced air. And earlier on, I mentioned that I would prefer to be looking at in-soil heat because we're dealing with a very low-growing canopy. Hopefully, we're covering that at night. And we don't need to heat the entire cubic volume of air inside of the greenhouse really to try to warm up the roots. It's in some ways very inefficient. And looking at our treatments here, again, I'm doing the conclusions first. At $3.50 a gallon for propane, a 500-gallon difference in propane used would cost $1,750. So are we getting a couple $1,000s of extra yield when we heat to pay for that? So to what temperatures were we heating? Again, forgive the Fahrenheit values here. One was 33 degrees Fahrenheit, so just above 0C. And the other, we went to 40 degrees Fahrenheit. Two side-by-side high tunnels at a cooperating farm. And the green series here is my lower temperature greenhouse or high tunnel. And the blue series is represents the soil nitrate availability, not in ppm, but in pounds per acre of the heated greenhouse. And you can see that there's a much higher peak, where we had heat, both early and late, which is to be expected, more of a steady state of low nitrate availability with lower temperatures. So heating the greenhouse definitely changes nitrate availability. And again, I'm heating the air here. Imagine if we had been heating the soil. You can see then a difference in the nitrogen uptake between those two greenhouses. So a low point here of 4.5% in the unheated house compared to the other one having a little bit more steady state. Now, I will point out that both of these are within what we consider the sufficiency range for spinach. So it's not that the unheated was deficient, it just simply has a lower level. And to a certain degree, that might be good. Less of a difference in spinach, or excuse me, in lettuce as compared to spinach. And a parallel trend in kale as well. Again, those values are actually quite high when we look at 7 and 8% nitrogen, actually probably too high. But again, the real question is that fuel use. And so you can see a dramatic increase in the gallons of propane we're using, about twice as much by the time we get to New Year's. Now, if I were to push this chart out even further, I think the trial ended at this point, but to include the months of January and February, you can imagine those two bars continue to widen over time. So the point I'm making here is that a very small difference in temperature has a very big impact on your input cost. So the difference between 33 and 40 degrees Fahrenheit, that's 7 degrees Fahrenheit, is resulting in thousands and thousands of dollars of additional inputs. Low temperature foliar results, you can see our nitrogen level is okay, but I'll point out some other very important nutrients here, potassium, magnesium, calcium, etc., all at deficient rates. Similar deficiencies across those secondary nutrients, although our NP and K are higher in our foliar uptake of lettuce in this case. So again, 3.49 nitrogen foliar mass compared to 4%, so about 0.5% off there. So we think early on that the warm soil led to increased nitrogen availability. The temperature is correlated with PSNT values or ppm of nitrogen in the soil and foliar nitrogen in the crop. However, by New Year's, when I'd already spent all that money on additional propane, there really wasn't a yield response worth justifying that. And I'll highlight here that Genevieve and I have spoken almost exclusively about nitrogen, because in some ways it's a very easy nutrient to study, or it's easier to study. It's easier to isolate. It is a very important nutrient. That's why we're having this today, is our initiatives around responsible nitrogen use in the province. But I think we have a long ways to go in understanding the other secondary micronutrients, particularly in cold soils. This is, let's see, this is Abundant Acres, where I had the privilege of visiting again a summer ago, and I want to highlight a lot of what's going on here in a way to undermine everything I've just said, which was a very reductionist approach of, let's look at a source of nitrogen, let's look at a rate of nitrogen, let's look at temperature. But I want to highlight everything that's going on here in this photo from Abundant Hill, which is you have a cover crop, a very nice buckwheat cover crop next to a crop in low tunnels, and then we have a caterpillar tunnel or a high tunnel with a tomato crop inside of that. And if I were to put winter spinach into any one of these three cropping cycles that we have on this image, the amount of nitrogen that would be available to that spinach is going to vary considerably. And so you as farmers are the most knowledgeable on the factors that are going to influence your fertilization rates, and knowing the crop history, the soil history, and being able to predict performance under different fertilizer rates, really your experience is invaluable. So the conclusions I have is that with source, even though we can inject nitrogen, we generally are looking at a meal. But that meal, if we're going to plant early being before the drop down below 10 hours of sunlight, we might think about including a product that has some soluble nitrogen in there, such as blood meal or Chilean. Our data on rate is very mixed, and I picked and pulled from probably 6 years worth of data there. And I think that the reason that our data is very mixed is due to, again, the influence of temperature, which varies considerably, and sunlight, which varies considerably winter to winter. And in some years, this data that I landed on, or this conclusion I've landed on of a rate between 130 and 200 pounds may not apply. It may be lower for a heated soil. And again, look at your own cropping cycle. Are you terminating your spinach crop in December, January, February, or March? In that case, you can back off of these nitrogen rates considerably. And I've run out of slides. And so I just want to say thank you again to Talia and Perennia and Genevieve for sharing the screen with me today.
Yeah, that was awesome. Thank you so much. We covered a lot of ground there. I feel like I'll need to watch that a few more times to really wrap my head around it. Okay, so I've got a few questions here. We'll start off with, you're talking about split application. How were you doing that split application if you were using primarily meals?
Yeah, so it's a manual application, so it's broadcast on the soil surface, and then it's hoed in, just scraped into that soil surface, and then ideally we apply some drip irrigation to wash it down, hopefully. Yeah.
Okay,
So
interesting.
yeah, in less than how are you going to do that in a very densely packed, fully mature crop?
And so you were doing that sort of like alongside raised beds, and then sort of.
Yes. Yeah. So the early
Okay.
application is easy, right? You can do that before. And then I don't recall the dates, but let's probably a month or two later, then trying to work that into a bed.
And how did you decide the timing? Like, were we looking, when you talk about split application, are we looking at 2 applications of nitrogen through that winter period, or are we doing more than that?
No, that was 2 applications, and it might be a good idea to do more than that, Talia. I think you might be onto something there. And then timing, I don't recall how we made that decision, nor do I recall the exact date of that second application. And I think that would matter a lot. For it to, the split application to make any sense at all, though, it seems like you would want to wait till at least January before you reapply, I'm guessing.
Yeah, that makes sense to me too. And I thought it was really interesting how you were talking about the use of row cover not as like a crop preservation or maintenance method, but let's focus on nitrate and like mineralization and microbial activity. That was really cool.
Good.
Have you kind of done like a side by side of like, this is where we did it and this is where we didn't? Like, are we able to sort of quantify that, or?
No, we should, and we should look at the nitrogen question in particular. That's a great question, Talia, but I think you and I have talked in the past about our winter cover cropping and high tunnels work, and there I have put down a row cover
Yes.
over half and not row cover over the other half. And yes, there are massive increases in total biomass where we have the row cover.
Yeah, okay. Lots of opportunity to play. That's good. We'll be busy. So you talked about doing a pre-side dress nitrogen test, and you were doing that to determine how much nitrogen to apply or when to apply. Like, what were you using that information
Yeah,
for?
that's a good question. You kind of exposed do as I do, not or do as I say, not as I do type of thing going on here, because we did a PSNT test, but we didn't change our nitrogen rate based on that PSNT test, which is what we would suggest to growers. And again, I think Genevieve has great data there with, showing 30 ppm of nitrogen, which is fantastic to work with, following on a cover crop. So that would be a case where I would encourage people to do that. We were doing it more from the research point of view of, here is my PSNT level, and here's what it looks like over time after I do all these different application rates.
No, absolutely. And when you're doing that, is it a soil test? Is it a tissue test?
Great question. That is a soil test, and generally that's available as a la carte test if you want it to be. I imagine, I don't know if Perennia helps with those processes or not in Nova Scotia.
I know we have like a soil nitrate test. Is that kind of what you're effectively running, just to sort of see what that available?
Yeah, I think so. Would you call that the same thing, Genevieve?
I think so, yeah. I don't know, why we call it a pre-side dress,
Well,
because you don't need to determine side dressing.
No.
People use it in corn though, to like
Exactly.
determine if they should side dress their corn. But you can
Yes.
use it also at the end of the season in a high tunnel or anywhere to see if you have a ton of excess nitrate in the soil at the end of the season, if you adjust your fertilizer applications for the following year, or if you should seed a cover crop to suck up that nitrogen to save it for next year, etc. So definitely not only about side dressing, but that's what we call it.
Yeah,
It's something we can kind of use at any point.
Yeah, so your nitrate test is probably the same, Talia.
Okay, awesome. So with that, guys, thank you so much for attending, and for sticking with us for that extra half hour today. I thought that was kind of a nice, let's focus on winter spinach and talk about it. So yeah, if you guys have any additional questions, any feedback, anything you would like to follow up on, feel free to reach out to myself and we can kind of get you sorted where you need to go. Thank you guys so much, Genevieve and Judson, for joining us, and hope we'll see you soon.
See you soon. Bye now.
Thanks so much. Bye.
Bye, guys.